Hey, welcome to the last part in this series on the quadratic function. It's been a long journey and we're going to go back now and use technology. We're going to finish as we started. The batteries aren't flat anymore and we're going to go back and see what technology has to offer to do all those things that we've been doing with the quadratic function. Just remind you now, this one and this one was our inspiration, I think, for looking at this function. All the applications of this particular parabolic shape in the real world. And so we went to the mummy or daddy of them all, y equals x squared, and we went on from there to various changes. Let's have a look at what the calculator will do, the Casio 9860 Plus graphics display calculator, and what we can do with it in investigating the quadratic function. So come on down and let's have a look at, here's the menu, and we're going to be working with three different areas of the calculator here. The first one is under that icon there, table, graph. We've done a bit before with Dynamo and Equa. And Dynamo we won't use much. That was a bit of a fun application to start with, and you can vary the function. But generally we will use the ordinary graph mode. We'll have a fixed function which we'll put in there and work around it. So let's go and look at what those three areas of the calculator can do for us. So first of all, let's have a look at one way of drawing the graph of y equals x squared. Remember, I said I'd found this function and I mapped these values from points on the curve when x was 2, y was 4, and we backtracked and we found that the formula or the model for that curve was y equals x squared. Well, of course, you can go in reverse. Just imagine I gave you this formula, which is a rule that all points x and y must obey if they're to form that curve. Okay, so that's the rule. So let's put in an x over here. Let's put in neg 4 into x squared. Neg 4 times neg 4 is positive 16. We would then go to neg 4 and plot positive 16. Can you see what we could do? Put in neg 3, square it. Neg 3 by neg 3 is 9. Plot the point. We could track this curve right out by the rule or the formula. The formula equation for a line is the rule that the points must obey. And we could do all of these here and plot all the points out and get a nice graph like that. This may or may not give us the turning point and the exact y-intercept because that could be in fraction land. We usually, when we make up a table, use integer values for x. And we get x values and we see, according to the formula, what the rule is for the y to go with those various x values, and we create points. Okay, let's have a look at that in action down here. Let's go back to this function. We've investigated this quite a bit. Y equals x squared plus 2x take 3. Let's go and put neg 4 in. Neg 4 squared will be 16, plus 2 by neg 4 be neg 8. 16 take 8 is 8. Take 3, got it, 5. Do it for neg 3, put it in there for x, and we come up with 0. And so we can go through all those x values. Would have to have these particular y's according to the formula so that you get points that will form this curve here. Okay, so that's the curve, or the graph for y equals x squared plus 2x take 3. And we still didn't nail this. Neg 1 here is neg 4, and we can see that that looks like the vertex there. Okay, it happens to be right on a point with integer or whole number values for its coordinates, so that was lucky. And also, this was whole numbers, and these were nice whole numbers. So it's turned out quite well. Table is not a bad way of plotting a graph without much mathematical knowledge. We've tried to be more powerful than that and work out x-intercepts and y-intercepts particularly, rather than just substituting in. But the calculator will do this table for us if we want it to. So let's go and look at that as our first application. So come over to this first window. Can you see I've scrolled to table? So you scroll around the menu screen with that button, and when you land there it's highlighted. So if you push execute, you go into this table function where you can put in a formula. There's our formula. Same one again. X squared plus 2x take 3. Push execute, and it's highlighted here. See the highlight there. And then we will want to set up a table. So here, look, there's table. So we're going to do that, but here's set next to it. So push F5 and the table setting comes up, and I reckon we'll do values like I just did by hand. Start the X value, here it is, at -4, go to 4 in steps of 1. Okay, now we've got to make sure we've got a window to see this table. So what we've got to do then is to come across, if we hit execute after here, here we go, x squared plus 2x take 3, and then if we hit table by hitting F6, we get a table, but now we can view this. So there's our table when x is -4, y is 5. It's a vertical table where I had a horizontal table. Okay, so this will go, you could scroll down with this button here and see the rest of the values from -4 to 4. And you could pluck those off the calculator and plot them on your own grid. Or we can get the calculator plot them on the grid, on a grid. So before we do that, let's go to Shift and F3 to get the view window. And I've got this view window here. This is the initial view window, a min x, -6%, 6.3, and I've added a little bit more here. I've gone further in the y from -5 to 10, just to open up that window a bit. Okay, you'll see why in a minute. So if we then go back and exit that back to this window, can you see gcon and gplot there? Let's do gplot. Hit F6 and you see them there? You can barely see them. These are the values for the function. And that one there, I think, it's very faint. It just plots the individual points. And that's what you do is if the function does not exist in between those points. But for our function, we could have x as 1/3, 1/2, 1 1/4. So we would have a continuous function there. So what we might do is exit that and you do gcon, which connects the points like a graph. So hit F5, and it's not a very good graph in this mode, in table mode. It's a bit wonky around here, but you do get the general shape. And that's, of course, what you do. You do gcon if values between the tabled values, between the tabled or tabulated x's are possible. In other words, we just put in whole numbers, but we know the rule would apply for all the points between those, an infinite number, so we indicate that by a smooth curve, indicates all the points in between are valid in this function. Okay, what do you think? That's one way of using the calculator. Let's go to another one. Let's exit right back and go and hit menu again, perhaps here now, and we get this menu. We'll scroll to graph using this button, and it's highlighted. Let's see what graph mode has to offer us. Okay, and this is going to give us all the points that we have been powerful enough now to calculate for ourselves. Turning point, intercepts, and so on. So let's have a look here. In graph mode, if you hit execute, you get this, enter the function. Okay, so this function will already be in there if you've entered it in table. The modes of table, diner, we did that in the first presentation, and graph all share this entry window of y equals. So it's already going to be in there. If you hit execute, it'll be highlighted, and then if you hit execute again or F6, it will draw the graph. Just check the view window. If you haven't set it before, check the view window, and so that you've got x from -6 to 6 or something, initial view window, and just make sure you go down and low enough and go a bit higher in y perhaps to just capture a good picture. So you just hit execute and you got that. Now that's good, but we want some details about it. The function we want to do or look for is GSoul. GSoul means solve the graph. So if we hit shift and then F5, we will get GSoul coming into action. And here it is here. Here are the options for GSoul. Look at what's come up here. Root, max, min, y-intercept, intersect. That's where two functions are intersecting. That sort of stuff. So, let's find where it cuts the x-axis. Now, here, Casio's called it a root, so you'll hit F1. Technically, it's not. A root is a root of an equation, and what the Casio is talking about is it's going to give you the root or solution, root means solution in mathematics, to that equation equals naught. So, roots really belong to equations, not to graphs. It would be better called, what? The x-intercepts of the graph? Or the zeros of the graph, where the function is 0, where it crosses the x-axis, y is naught. But anyway, they call it the root of putting the function equal to naught equation. So hit F1, and what happens? Here we are. Here the crosshairs pop on the first root to the left, the smallest root, smallest x-intercept, which is -3. Then if you scroll with this button, you get across to 1, and here it is over here. We've scrolled there, and the answer's down the bottom. X is 1, and of course y is naught, because all along the x-axis, y is 0. We've been doing that for some time now. All right, so what can you do? Well, let's exit that and draw the graph again and shift F5 again. And you could choose max. Well, this function hasn't got a max. It keeps going. A maximum. But you know down here it's got a turning point. Yeah, it's got a minimum. So let's choose F3 to see if it will find the minimum for us. And yes, here the crosshairs popped on the vertex, which because this is convex or concave upwards, there's the vertex. -1, -4, and that's a minimum. So this is a powerful function on the calculator, this GSoul function, which will give us all the points we need here. So come down and let's do something more. Let's exit that, graph it again, shift F5 again, and this time what are we going to do? Let's go to the y-intercept. Okay, by choosing F4, the crosshairs appear again. This time on the y-intercept, and of course we know all along the y-axis, x is 0, and so here it's x is 0, y is -3. So when we state this, we should state it as a pair like that. Okay, it's doing well, this function. Let's keep going and execute and draw the graph again. Hang on, we'll just go back up. It jumps ahead of us here. And what's the next thing that we could do? Well, we could do intersect, but that's an intersection of two graphs. So you'd have to have two graphs entered, y1 and y2 or something like that, so that it could find the intersection for you. And by the way, that point of intersection or any point you're finding with GSoul should be visible in the view window. Otherwise it will say not found. So don't forget VWin, adjust your viewing window so that GSoul can find the point. Okay, well that's all on that page, but look at this. There's more. So if you hit F6, we get these other options. Now this one is from calculus. It's the integral, so you won't use that just at the moment, but you could use ycalc. So let's choose F1. And it says, if you want to know the y value to go with any particular x value here, for the point to lie on the curve, then, okay, stick your x value in. So up comes x, and you can enter, what have I done? 2. And if I enter 2 and hit execute, it says you entered 2, Huddy, and the y value to go with that is 5. And it shows you. There it is there, 2, 5. And of course you could, look at this one, you could say, well, I know the y and I want to backtrack to the x. If I know the y, can I backtrack to the x and find the x values that go with a particular y? So it'll do all sorts of things for you, and hopefully, remember, you have the power now, hopefully you can actually do this if your batteries are flat. That is, with just maths and not needing technology. That's what we're aiming for. Budding young mathematicians need to do that. Okay, let's work on. And what's the final one? I told you we were going to go to equa. Equa stands for equation. And again, scroll to that position with a button and then hit execute, and let's see what equation mode has to offer here. All right, so there we are. Equals highlighted. Execute. Here are the options for equations that the calculator will handle. F1 is simultaneous. That means you've got more than one equation. You're working together. We did that with some linear equations, if you remember. Polynomial, that's what we've got. Remember, a quadratic is the simplest polynomial. It's a gateway to all the polynomials. It's polynomial because it's got more than one power of the variable. Poly meaning many. So it's got an x squared, an x, and an x to the naught, if you like, or no x term. There. Okay, and then solver. Now, solver is a bit hard to use, particularly at this stage. You've got to know a bit about the solution. So I'm not going to talk too much about solver there. What I'm going to do is say, let's choose F1. So here we are. And it goes into this window. And it tells you somebody's left data in there. Don't worry about that. It's asking you, what degree polynomial have you got? Have you got degree 2? Yes, you have. Degree 3, what would that look like? Or ax cubed plus bx squared. The degree of a polynomial is the highest power you've got. Okay, polynomial, many powers, and its degree is the highest power. So cubic would be degree 3. Well, we haven't got one of those. We've just got a quadratic. So we will choose F1. And then it says, oh, there's already one in there, so that's what they're talking about, data exists in the memory. If you want to solve this equation equal to naught, so this doesn't draw graphs, this mode. It only solves the equation for where the graph cuts the x-axis, that is when y is naught. So you have to put in your particular quadratic. A, B and C have to be entered in these holes. A, B and C, and then it will solve it for you. So let's do that now. See how this is highlighted? Always pop on there first. Come down to this next calculator down here, and I'm going to enter 1, and then push execute or go across with this. No, you can't push execute, so it'll solve the equation. Go across to the next spot, and then to the final spot. Can you see what I'm entering here is 1x squared plus 2x take 3. So that's a 1, a 2. Watch this. That's got to be the negative sign in there, neg 3, because we're entering these values, A, B's and C's, not the negative as an operator. So it's got to be negative in brackets, neg 3. And if you then hit execute or solve, there's solve F1, then it produces the answer. And this one's highlighted, so it puts it over here. So that's x is 1. Or x is neg 3. Now, I don't want you to be too corrupt here, but do you see that you could get out of factorising an equation, couldn't you? Let's have a look. X squared plus 2x take 3 equals naught. Now, we usually say, no factor law, you have to factorise. So x and x, let's say you can't do it. And you go into this mode on the calculator and you find the answers. Uh-oh, you could backtrack. If x is 1, what would this factor have been? X take 1. Just check it. If that was x take 1, x take 1 equals... Well, it's the opposite sign, isn't it? Remember that? Because you're solving the equation. If the answer is neg 3, this would have had to be x plus 3. Because when you put that equal to naught, x equals neg 3. Uh-oh, I don't think you should do this. This could be cheating a bit. But you could actually solve it if you had technology and work out what the factors were, working backwards. Okay. Well, generally, what we want you to do is try and work out how to do this properly. Okay, you have the power, remember. What if your batteries are flat? Okay. So that's the final presentation now. Just bring it all together. I hope you feel really up close and personal with quadratics, because that's the way maths is fun. If you really see it and see all the different ways of working stuff out. Okay, well, I don't know what you'll be doing next, but there'll be a presentation for you. I'll catch you then. Cheers for now.